to FlippedHarber for Algebra 2. In this video we're going to be looking at operations with functions. Our objectives for this lesson are to learn how to add, subtract, multiply, and divide functions, and we want to learn how to write and evaluate what are referred to as composite functions. Our outline for this video will start by looking at the different operations with functions. Then we'll move on to talking specifically about how to add and subtract functions, how to multiply functions, how to divide functions, and then we'll end by looking at an idea called composite functions. Now the operations that we're going to look at, addition of functions, means that we're going to be taking a look at what happens when we express f plus g of x, which is really just simply f of x plus g of x. Similarly, subtraction, f minus g of x, means that we're going to take the function f of x minus g of x. Pretty straightforward, pretty simple. F times g of x means that we take our two functions f of x and g of x and multiply them. And similarly, when we take f divided by g of x, that means we're taking the function f of x and dividing by the function g of x. Now sometimes things will cancel here, but a lot of times we'll end up making a rational function, something that we've looked at already. And then we're going to end today with the idea of composite functions. Now that is not an O between the f and the g. That's an actual symbol that means the composite of the function, and it's read f of g of x, which means that we're taking g of x, the entire function, and actually plugging it into f of x. But more about that later. First, we want to take a look at adding and subtracting functions. It's pretty much as simple as it sounds. We want to take f of x equals 8x plus 13, and we want to add g of x equals x squared minus 5x. Now, that means that we're going to symbolize it with f plus g of x, which just means take the whole thing f of x and add the whole thing g of x. Now, about the only thing I can do here would be to combine like terms. I've got the 8x and the minus 5x, and to put them in kind of a standard form, put our highest power first. We'll put the x squared first, plus 3x plus 13. Really very straightforward. You're going to have an easy time with this stuff. Now you do need to watch out a little bit when you're subtracting the two functions, because there's a very common mistake to forget that this minus in front of g of x is going to apply to both the first part, the x squared, and the second part, the 5x. So don't forget that that minus gets distributed in. Again, this time when I combine like terms, when I put it in my standard form, things are going to look a little bit different. Negative x squared, because that negative multiplies in. And now I have 8x plus 5x, which is 13x plus 13. Okay, so just watch out when you're subtracting that you make sure that you distribute that negative through. Now, multiplying functions, we've multiplied functions before. We're just learning some notation here where we're going to take f times g of x, which means that you take the entire function f of x and multiply it times the function g of x. Now you got to remember here, we're going to FOIL. So when I get all done, first, outer, inside, last, I'm going to have 2x cubed, and then I'll have 2x squared from the outside plus 2x squared from the inside, so that would be plus 4x squared, and then the 2x times the 1 for the last, I have plus 2x. So you want to go ahead and do the multiplication, combine like terms, put it in a standard form where we have the highest power first. You've done all of this stuff before. We've multiplied polynomials before. We're just putting some new notation in front of it, this f times g of x. That's really the new part here. So let's take a look at dividing functions. So what we've got to do is divide our two functions now. F of x is 2x squared plus 2x still. G of x is equal to x plus 1. F divided by g of x means that we put the whole function f of x on top, put g of x on bottom. Now we want to cancel where we can. We've done this before. We've worked with rational functions before. If I can factor, I should. So I'm going to factor out a 2x from the top, and that's going to give me x plus 1, and that x plus 1 can cancel the x plus 1 on the bottom, and I'm left with 2x. Now, because f of x and g of x were just polynomials, up at the top, the domain and the range for f of x and g of x were all real numbers. Or, maybe the range was a little bit limited, but the domain was all real numbers. Now that we created a rational function, the function f divided by g of x does not have a domain of all real numbers. Remember, as soon as we put that g of x in the bottom, I can't have a 0 down here. So x cannot equal -1. We made a new function that's got to live by some new rules. Let's go ahead and talk about composite functions, where we are literally plugging one function into another. Now, I think it's actually easier to talk about composite functions when we've got a number to plug in for x. So we're going to take f of x equals 3x squared, g of x equals 7 minus x, and we're going to find the composite function. Now, this is red, starting over here on the left, f of g. That's not an O, it's a symbol, kind of like, a big multiplication, but it's not multiplication. It's just a symbol. F of g of -5 means that we're going to plug -5 into g, and then whatever number we get for g of -5, that's going to get plugged in for f. So, first we'll find g of -5. Not too difficult. Plug -5 into g, we get a positive 12. So now what I'm going to do is find f of 12, because that's what g of -5 is equal to. So when I plug 12 into f, I get 432, which means that f of g of -5 itself is equal to 432. So we plug a number into the inside function, we find out what it's equal to, and then we take that number and plug it into the outside function. So to me, when I like to think about it, my first function is my outside function. That's actually gets done last. And then my g, my second function, is my inside function. That gets done first when I'm doing composite functions. Okay, now we're going to have to get across an idea here. So things look a little bit different here. Now I'm finding g of f of -5. So I'm going to plug that -5 into f, and I get 75. 3 times 25, 75. Now I take that 75 and I plug it into g. G of 75 is equal to a -68. So now g of f of -5 is equal to -68. Now what's important here is very, very, very rarely does f of g equal g of f. There's very special case situations where that's true, but I just want you to assume always that f of g does not equal g of f. And then if it happens to be equal, it's just, a cute little miracle. So let's take a look at this where we don't have a number to plug in for x. Okay, I've got f of x equals x squared. I've got g of x equals 2x minus 3. I'm not going to plug in -5 for x. I'm going to deal with f of g of x on its own. So I've got to find f of g of x, which means that my g of x, this whole 2x minus 3, gets plugged in for this x right here in f. Now, what could I do from this point on? Well, I could go ahead and I could FOIL it. I would get 4x squared minus 12x plus 9. Okay, well, let's go ahead and look at what g of f of x looks like. Now things are getting switched around. Now, instead of the 2x minus 3 going into the x squared, now the x squared goes in for this x right here. So g of f of x means that I build g around f. This is a weird idea. You're going to struggle with this a little bit until you get comfortable with it. But g of f of x in this case is just 2x squared minus 3. I don't even really have anything to simplify, so I just write it down as my answer, and I'd move on. Now let's take a look at one where things get a little bit weird. f of x is still equal to x squared, but now I've got this new function, h of x equals the square root of x minus 1. The reason I'm talking about this one is so I can talk about the domain. I can plug anything I want into this x squared. I can plug positive numbers, I can plug negative numbers, I can plug 0. That is not the case with the square root of x plus 1. This x plus 1 has to be greater or equal to 0, which means that x has to be greater than or equal to negative 1. If I try to plug negative 2 into this, the square root of a negative number, we don't really want to deal with. So the domain for this one is a bit limited, and we have to remember that. Okay, we're about to build a composite function, and anything we build off of f of x or h of x kind of brings along these domain limitations. So let's take a look at f of h of x. So I'm plugging the square root, the whole thing, into x squared. Now, cool thing, that square root cancels, and I have x plus 1. But because a piece of it was limited, I could only plug numbers greater than or equal to negative 1 into h of x. We bring along those limitations. So even though it doesn't look like there's a problem, I still have to say that x has to be greater than or equal to negative 1. If I switch it around, find h of f of x, now that x squared is getting plugged in for the x, now the square root doesn't cancel out the square. So now I need to address that domain problem again, where this, the stuff inside the square root, has to be greater than or equal to 0. And I say that x squared has to be greater than or equal to negative 1. Well, this isn't a problem. X squared is always greater than or equal to negative 1. So not a problem here. This doesn't limit our domain, but because one of the pieces that we made it from had this limitation, this too, x has to be greater than or equal to negative 1. All right, so that's going to be it for this video. Now it's time for you to try some of this on your own. I'll see you in class, and I'll see you online.